Okay, so this is the topic for sampling theory and estimation of parameters. So the interval of the upper and lower. So this is the lower confidence limit, and the upper confidence limit is computed from the selected sample called confidence interval 100, then multiply by 1 minus alpha in terms of percent. So the fraction 1 minus alpha is called confidence coefficient. Okay, so estimating the mean. So if the mean is the x bar, if the x bar is the mean of the random sample size of n from a population with known variance, okay, or standard deviation, okay, so the confidence interval for the mean is given by this equation. Okay, so where z alpha all over 2 is the z value leaving an area of alpha all over 2, that is to the right, or this is also called the what you call this, alpha levels z-score. Okay, so make sure that it leans to the right. Then the values for random variables for the lower and upper confidence limits are given by this equation. Okay, so this is the mean, and then the alpha levels z-scores multiplied by the standard deviation all over the square root of n. So okay, that is plus or minus probably. So plus for the upper and minus for the lower limit. Okay, and these are simply the notes. So if the x bar is used as an estimate of mean, it can be 100, then multiply by 1 minus alpha, percent confident that the error will not exceed, okay, this value. And if x bar is used as an estimate of mean, it can be 100 and then 1 minus alpha, percent confident that the error will not exceed the specified amount of e, okay, when the sample size n is equivalent to the alpha level, the z-score, and then what you call this, standard deviation, then error. Okay, this is the margin of error e. Okay, margin of error e, then square. This came from the equation given uh, when solving for n, okay, for the margin of error. So let's try this example. So the average zinc concentration recovered from a sample of measurements taken in 36 different locations in a river is found to be 2.6 grams per millimeter. So find the 95% confidence intervals for the mean zinc concentration in the river. Assume that the population standard deviation is 0.3 gram per millimeter. Okay, so find the 95% confidence interval. So that gives us, using the formula for estimation of the mean. Okay, so based on the given, we have these 2.6 grams. Okay, this will be our sample mean for the x bar, and then 0.3 gram standard deviation. Okay, you have here the value of x bar as 2.6, and then standard deviation of 0.3, and n is taken as 36 for the different locations. Okay, so you'll have 2.6, okay, and then the alpha level score, or alpha levels z-score. How did they solve for 1.96? Later on I will discuss this one. Standard deviation of 0.3, and n, okay, is 36. Same goes to the upper limit. Okay, 2.9, 2.6 for the X bar. Then 0.3 standard deviation and is 36. Okay, so how did we arrive to solve for 1.96 for the alpha levels z-score? Okay, it depends on the confidence interval, which is 95%. Okay, so let us use the z table. This is the z table. Okay, so z table. Okay, so first we need to determine the alpha level. Okay, so the alpha level is, for example, we have a 95% confidence interval. Okay, we will subtract this from 100%. Okay, so 100% minus 95%, that gives us 5%. 5% represents alpha. Okay, so this is 5% all over 2, so that gives us 2.5%. Okay, so from that 2.5%, we will subtract the 2.5%. Okay, so how do I provide this one? Okay, so let me just use a word. Okay, so the first step will be find the alpha level. And then, so we have a, let's say 95% confidence interval. Then we will have to subtract that value to, let's say, 100% minus 95%, so that gives us 5%. Okay, now for step number 2, so this is step 1. Step is divide this value, so we need to divide this value by 2. Okay, so that gives us 5%, then divide it by 2, so that gives us 2.5%. So for the step number 3, subtract that value, or subtract value to 50%. So that gives us what you call this, 50% minus 2.5%, that gives us 47.5. Okay, step number 4, add 50% value. and convert the answer to decimal. So that is 47.5%, okay, plus 50%. That gives us 97.5%, or approximately equal to, say, 0.975. Let's say, yeah, okay. Now, by the way, this is the using the z table in determining for the alpha levels z score. Okay, now we have a value of 0.9750. Okay, and from that value, let us simply go to the z table and look for 0.975. For the value of 0.975, 975, there it goes, 975. Okay, 0.9750. So 9750, you have 1.9 plus their intersection is 0.6. So that gives us 1.96. Okay, so we could say that the z alpha, okay, so let's say insert symbol for alpha over 2 is equivalent to 1.96. Okay. So you have a value of 1.96. That's how they computed this confidence or alpha level z score. Okay, so we know how to solve these alpha levels z score. So 1.96. So using your calculator, you can simplify. Okay, and then you have this 2.5 and then 2.7. So the 95% confidence interval for the mean zinc concentration lies between 2.5 and 2.70. Okay, hope that the computation for the alpha level z score is clear. Okay, with these possible steps, okay, using the z score table, okay, or the z table provided under module 7. Okay, the z table standard normal distribution. Okay, now going back. Okay, so estimating the mean, let's try this one. So similar 36. Okay, similar problem for example 1, but then you need to find the 99% confidence interval for mean zinc concentration. Okay, so standard deviation still similar, 0.3. So you have 0.3, 36 for n, and 2.6 for the x bar. Okay, similar. Then the z alpha all over 2, all the alpha levels z score is given as 2.575. How did he arrive for the 2.575? Since 99% confidence interval, okay, so let's say this example 1, A, let's say A, okay, then I'll just copy this one for the B. let's say B at 99% confidence. Okay, so this is 99%. Let's try 99%. So you'll have a 1% here. Then 1% divided by 2, you'll have 0.5%. Okay, you'll have 0.5, so this will become 49.5. And then you have 49.5% plus, so you'll have a 99.50, okay, or 0.995. Okay, now the z-score, so alpha level z-score using the table, 0.995, 995, 995, 5, probably 995, this one, this one. Okay, so 9952, 99506, and 02. Okay, if you're going to add this one, so it should be 2.57, but then its answer is 75. Refer to this value. Okay, let's see, 99492. Okay, let us use a calculator. So that gives us 0.99, this one. Okay, so 0.99492 plus 0.99506. Then, okay, so you need to get the average probably for this particular value. Okay, so you have the average of those two values in between. That's why he used 2.57, right? 2.57, 2.57, and the interval between these two is 75 between. Okay, so you have 2.575. Okay, so this is probably 95 if you round it to the 3 decimal places. Okay, so you'll have a value of 2.575. Okay, for example B. Okay, so hopefully you have a clear understanding on the how to solve the alpha levels z. By the way, I will be also upload this uh, word so that you have a copy of this one. Then, so estimating the mean. Okay, so continuation for the uh, problem 1. Let's say this is example 1C. Okay, how large a sample is required if we want to be 95% confident that our estimate of mean is off by less than 0.05. So when we say the estimate of mean is off, this is the margin of error E, okay, on your formula. So solving for the sample, okay, so how large is the sample? Using this formula, you have this alpha level z-score of 95%. You have 1.96. We have solved this one. And then the standard deviation of 0.3 based on the given. This is just a continuation of the previous problem. Okay, and then 0.05 is the margin of error. Okay, and then squared. So you'll have 138.3. So since this is the sample size, you need to round it up. Okay, like for example 138.1. should be 139. Okay, so the answer is 139 for the required sample size. Okay, let us continue for example 2. Okay, now a random sample size of 100 automobile owners in the state of Virginia shows that an automobile is driven on an average of 23,500 kilometers per year, with a standard deviation of 3,900 kilometers. Assume the distribution of measurements to be approximately normal. Construct a 99% confidence interval for the average number of kilometers an automobile is driven annually in Virginia. Okay, so you have your X bar here, and this is your standard deviation of 3,900, and n is 100. Okay, so alpha level z score, we have solved this from example 1b. Okay, then standard deviation, square root of 100, so minus for the lower limit and plus for the upper limit. Then simplifying, you'll get an answer of 22,495.75 for the lower limit, and the upper limit is 24,504.25. Okay, so estimating the difference between two means. Okay, so x bar 1, x bar 2 means are the means. So these are the means of the independent random sizes of n1 and n2. N1 is respectively to the mean 1 and mean 2 is for n2 population. Okay, and known variances. Okay, and respectively, so confident interval for k mean 1 minus mean 2 is given by this equation. Okay, alpha z score or alpha level z score is computed similar to our previous problem. Okay, but then the equation, okay, since we are estimating the difference between the two means, so we need to use this formula. Okay, so for example 1, a study was conducted in which two types of engine, A and B, were compared. So you have your comparison here. So gas mileage in miles per gallon was measured. So 50 experiments were conducted using engine A. So N1 for A is 50 and 75 experiments for B. Okay, so gasoline use and other conditions were held constant. So the average gas mileage was 36 miles per gallon for A. So this will be the so the mean for A, so mean 1, X A, X bar A. Okay, and then for B, you have 42 miles per gallon. So find the 96% confidence of interval of mean B minus mean A, where mean A and mean B are population mean gas mileage for engines A and B respectively. Assume that the population standard deviation are, okay, so these are the standard deviation for A and B respectively. So using the formula, okay, and then for XB, okay, you have a 42. Okay, so that is the average gas mileage, and 36 for XA. Okay, and then the alpha score later on we will compute that one. Standard deviation 6 and 8, so it should be A 6 and then B is 8. Okay, and then similar on this side, but then this is the lower limit, this is the upper limit. Okay, now let us solve for the alpha level z score. Okay, we have a, what you call this, 96% confidence interval. Okay, so let us use the previous example here. So I'll just copy this one. Let's say difference two means. Example 1. Okay, so you have 90, how much? 96%. So that gives us 4%. So this should be 4, and it should be 2% here. So 50 minus 2%. So that gives us 48%. And so 48 plus 50, that gives us 98% or 0.98. Okay, so the alpha level Z score, refer to the Z table, 0.98. Okay, 98, 0.98. Okay, so 9807, 97. So if you're going to get this average, let's try to get those average of these two. So you'll have what you call that, 0.97982, 0.97982. Okay, then plus 0.9803. 03. Okay, then divided by 2, so 9806. Okay, so in between probably, so 2.05. Okay, so your answer is 98. Probably it should be 2.05. Okay, 0.55 probably. Okay, but then use 0.5. Okay, and then because this exceeds 9806, so it exceeds 0.98, the exact value, so he uses 2.05. Okay, so that will be our alpha level Z score, and then simplifying these equations, that gives us the lower limit and the upper limit. Okay, and then continuation, n1 is taken 25, so random sample size of n1 25, taken from the normal population with standard deviation of 5 and 1, then standard deviation 1, and x1 of 80. So that's the mean. Okay, and the second is has a sample size of 36, taken from a different normal population with a standard deviation of 3, okay, and a mean of 75. So find the 94% confidence interval. So similar procedure from the previous problem using this formula. Okay, but then the alpha Z score, let's try to solve that one. So let's copy this one. So this is 2.05. Forget to place it. Then let's say this is example 2. So this is 94%. Okay, so 94%. So that gives us 6%, 6%, 3%. So this is 3. We'll have 47, 47, then 97. So 0.97. So on your Z table, 0.97. Okay, 97.5, 9706. So probably I will choose this one, 97. Okay, so 1.88. Okay, you have here 1.88. So that's how we computed the alpha level z-score, 1.88. Okay, so hope that this will be clear to you. Okay, then you have simplifying that those equations, you'll have this lower limit and upper limit, okay, between the two means. Now estimating the variance, okay, you'll have this formula. Okay, this is n minus 1, then s is called, okay, estimator of the variance. Okay, and then n minus 1 will be your probably degrees of freedom, then this will be the variance. And for this value, this is the degrees of freedom. So this is estimating the variance. So this is the interval estimator, and this will be your formula for the variance itself. Okay, this is the variance. Okay, you have this formula. So this is the degrees factor. Then this will be the variance of the random sample, and this will be the uh, values between the degrees of freedom. Okay, we will be using the chi table. Okay, it is included on your module week 8, okay, chi-square table. Okay, now let us try to solve this value or this example. So estimating the variance, so the following are the weights in the decagrams of 10 packages of grass seed distributed by a certain company. So 46.4, okay, 45.8, 47, 46.1, and so on up to 46. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is 10 based on the given. So find the 95% confidence interval for variance of the weights of all such packages of grass seed distributed by this company, assuming a normal population. So using the formula for mean, summation of x all over n. So you have add all those values, then divided by n, which is 10. You'll have the mean for 46.12. Okay, and then solving for the variance of the sample mean of the sample given. Okay, using this formula, you're familiar with this one. It has its, so x minus mean, where mean is 46.12. So x refers to 46.4, 46.1, and so on. So 46.4 minus mean square plus, okay, 46.1 minus mean, then square, then 45.8 minus mean, 47 minus mean, and so on. Okay, up to the last part of 46. So 46, okay, minus, then the whole equation, okay, is divided by simply 10 minus 1. So you'll be noticing 10 minus 1 here. It should be 10 minus 1 here and 10 minus 1 here. It has a continuation. So this represents only a single denominator. So it should be these numerators, okay, when you sum them all up, okay, will be divided to 10 minus 1, a single denominator, which is divided by 9. Okay, and then you have a standard deviation of 0.28, variance, I mean, of standard 0.2862. Now, solving for the 95% interval for the variance, okay, so you need to use this formula. Okay, so n minus 1, so 10 minus 1, then the variance itself, okay, and then all over this value. Okay, you will be using the what you call this, chi-square table. Okay, so n minus 1 similar on the other side, then square, then look at the difference between the formulas. Okay, so this is x alpha all over 2 then square. If you're referring to the chi-square table, so that is x squared, okay, alpha over, so alpha. Okay, so this is alpha all over 2, so we'll be using a 95% confidence interval, similar procedure. Okay, so let's try this one. Copy that. So let us try to use what problem is this? Estimating variance. So solving for this should be x, then squared probably. So let us just copy this one and provide it to this one. Okay, so similar procedure. Okay, you have your 94, 94, 99, 94. Okay, so we have this 94%, should be 95%, 95, 5%. So 5% divided by 2, you'll have 2.5%. And we will stop there. 2.5%. Okay. So alpha all over 2, you have your alpha here. So I'll just remove this one. Okay. Then step 3. That refer to the chi-square table. Note the degrees of freedom equivalent to n minus 1 is equivalent to 10 minus 1, which is equivalent to 9. Okay, so 9, you will be referring to this value using the chi-square table. Using the chi-square table, degrees of freedom, or df, is 9. Then x alpha 0.25. So this is equivalent to 0.025. So it should be, this value will be 0.025. Okay, so 0.025. Okay, and then along 9 degrees of freedom, you'll have 19,023. So 19.023. Okay, and then the x minus 1 minus 0.025. So 1 minus 0.025 is a 0.9975. Okay, 0.975. So that is equivalent to 0.975. Degrees of freedom of 9, so you'll have 2.7. Okay, so this is 2.7. Okay, so we'll have this value under degrees of 9 of freedom of 9, which is 2.7. Okay, so hope this is clear. Where did I get this 2.7? I did subtract 1 minus, okay, 1 minus 0.025. So this gives us 0.975. Then referring to the chi-square table, 975.975 under 9 degrees of freedom is 2.7. So that's why he uses 2.7 for this value. Okay, then simplifying, you get the variance, okay, for the 95% confidence interval of 0.1354 for the lower limit and 0.954 for the upper limit. Okay, so that this ends our module.